Okay. Hello. Welcome back to the OpenSearch deep dives. After a few weeks of doing deep dives on the indexing code tab, I realized waiting until I finish with indexing to get to search, it's going to take a little while. And I've had a few people reach out to me asking, hey, when are you going to start on search? And so rather than waiting until I finish with indexing, I decided, you know what? I can do this twice a week. So Mondays will be indexing deep dives and Thursdays will be search deep dives. So yeah, this is the first in the series of search deep dive. The good news is that unlike with indexing, this is actually code that I know quite well. So the search deep dives could go a little bit faster, because I'm not learning the code as I go along. So like with the indexing deep dives, the entry point will be one of these REST actions. Now, again, there was a video that I did sometime last year where I did get into, there's this REST controller. It has these handlers registered, and in action module, there's this, so on node startup, all of the possible REST actions get registered. And this is how the plumbing is set up to map from a particular HTTP URL to, a specific REST action. So for the search side, that's REST search action. So the possible HTTP URLs that get handled by this action are, underscore search, get or post, or, you can scope it to an index or index pattern, and then, follow that by underscore search. So URLs that end with underscore search without, an intermediate slash, will get routed to this particular action. You may recall, if you followed the indexing deep dives, the base REST handler has a handle request, which calls this prepareRequest. And the base REST handler takes a REST request, calls prepare, and then, eventually, sets up this channel, right? So, it's received the channel. The action, the channel consumer, is what is returned by prepareRequest. And so it's mostly the job prepareRequest to say, given this REST request, here's what I, as this, this REST request is any old REST request. And so, base REST handler will call prepareRequest to turn into to get the appropriate consumer. And that consumer is what's going to actually do the thing. So prepareRequest is the magic method that tends to, that each of these REST actions will. So on the search side, it looks really short, which it's deceptively short. In fact, the big thing is that, most of the logic doesn't actually live in prepareRequest, but rather parse search request, which is not that short. So this is the thing that, so we constructed an empty search request, and essentially we give this method the REST request and the search request, and it ends up going through and calling all these setters, right? So most importantly, the search request, we always end up setting the source to something not null, because the bulk of what you're getting in your REST request. So this part confused me a little at first. Let's look at search request actually for a sec. So search request, in terms of its fields, doesn't actually have that many fields, really, right? So, here from line 87 down to 124, yeah, we've got these fields. They're all spaced out by 2. So what? That's fewer than 20 fields. Yeah, and this one here is actually just constant, you know, setting. Yeah, or not a setting, I guess. But yeah, a constant that I believe is loaded from a setting. Yeah, something like that. Yeah, option. Yeah. So anyway, all that to say, these are values that are passed as get parameters, as URL parameters. Now, of course, when you send an open search use case, really the bulk of what you're doing, or when you're sending a search request, it's the bulk of it is in the body. Well, and that's the search source builder. So search source builder, we look at that. Well, this thing, yes, there are lots of different fields that get parsed out of it, and as you can see, there's quite a lot going on here, right? So this is where you've got the actual query. You've got, these Boolean flags for, oh, I want explain tree. We have these derived fields. You can specify highlighting. You can specify the aggregation. So all this stuff doesn't actually belong in search request, but rather in search source builder. So as we come back here to REST search action, okay, so first off, we do read the HTTP URL parameters, right? So, this batch reduce size, you would do like question mark batch reduce size equals blah. Same thing with allow partial search results. And so you know, first we handle those HTTP params, and then we call over here to parse search source. So with this one, this is where we actually set up that search source builder. So from the request, now there are some things that URL params to query builder. Oh, of course, yes. This is something that those of you who've come from Solar may recognize. People don't usually use OpenSearch this way, but I believe this is something that goes way, way, way back. Git annotate with git blame. Yeah, 2010. 2010 from commit that says initial commit. So yeah, this goes all the way back to the beginning of Elasticsearch prior to 1.0, I think, where Solar uses this model where queries are passed as URL parameters, specifically with a Q parameter for Q for query. So yeah, you can still do that with OpenSearch. You can specify the default search field with df, which also is very much a Solar thing. Sorry, I'm just going to try to figure out how to get rid of the keyboard selector. Oh, stop popping that up. Okay. Anyway, so this is something that's probably not very frequently used, but it's still there. So some of the URL parameters do get mapped to the source. In practice, most people are never actually going to use these things. And so, yeah, we're going to go through and, okay, some of the other URL parameters. Well, yeah, this is sort of a historical thing where from size explain, you can either specify them in your URL or you can specify them in the body of your search request, in the source of your search request. So yeah, you can do either. And what ends up happening is, this I find a little bit confusing. That let me double check this. Because I would have thought that the URL parameters would take precedence, right? So you'd want the, wait, we'll track that. So we got here to parse URL source. Sorry, we were in SearchSourceAction, parse search request. Have we actually, when we call this parse search source, have we already parsed this source? Source. Yes. Yep. So, yes. So this method, I, yeah, am not a big fan of the naming. I would call it something more like, I don't know, override search source with URL params. So yeah, that's a better name for it. I don't plan to commit this existing name was, well, a bit confusing. It's okay. So yeah, so the URL parameters actually take precedence over the body. So if in the body you've specified the size parameter, for example, and then in your URL, you also specify a size parameter, the one in the URL wins, because the bulk of the body is actually parsed here. So this parse XContent. So this is a recurring pattern that comes up in a few places in OpenSearch. I don't believe I actually got into a parse XContent example on the indexing side, which actually kind of surprised me, because that's something that would have also been relevant for indexing. I guess the big thing is that on the indexing side, we tend to take document source as JSON and just pass it right through. Whereas on the search side, it's like, no, we actually have to interpret that JSON right away. So when you see the word XContent, in the back of your mind, you could kind of replace XContent with JSON. That's not actually true, because XContent is generically one of several formats. So XContent as the interface, we look at the subclasses. So there are actually 4 different implementations of XContent: CBOR, JSON, Smile, and YAML. In practice, I don't know of anyone using CBOR or Smile to handle OpenSearch content. JSON, of course, is the one most commonly used for REST requests. You can, like, I wouldn't, as a developer, I wouldn't want to send YAML search requests, but I could. So anyway, so yeah, XContent sort of handles generically parsing these things out. One of the slight downsides, in a way, with the use of XContent is that, it is, if I recall correctly, there are a couple of things that you can do in JSON that you can't do in YAML. And so XContent, I think, will be limited by the lowest common denominator. In practice, you can tend to look at XContent as handling anything that JSON can do. So yeah.
And perhaps not coincidentally, those 4 implementations all have Jackson libraries that,
Yes. Yeah.
and that's probably why those 4 are there.
Right.
Because they ultimately, the only implementations that exist are those 4 that delegate down to Jackson libraries that I think have very, very similar sort of parse and generate APIs. And so they end up being quite similar.
Yeah. And this is one of those things where, as someone who's used the Jackson APIs directly in the past, having this abstraction layer that sits on top of Jackson doesn't feel that useful to me. Where it's like, sure, we have all this XContent syntax, all this XContent stuff going on, sitting on top of Jackson. It really doesn't feel like it's adding that much to me. I'd be pretty happy just using Jackson directly. But, well, this is what it is. Yeah.
Yeah, I wonder if historically it was different. If
Yeah.
I don't know, but now it's all like pretty straight pass through to Jackson in all these cases.
Yeah. Yeah. Maybe at some point, like Jackson certainly had its ups and downs over the years. It could be that once upon a time there was the thought that's like, okay, well, maybe Jackson won't be, this multi-format parser and especially a good JSON parser. Maybe we get replaced by something else. But no, Jackson's held on, and yeah, it's still pretty popular. Yeah, keeping in mind this is a code base that goes back at least 14 and a half years, right? That that the initial commit that we saw here was February 2010. So yeah, a lot has changed over the past 14 years. Well, almost 15. So yeah. So anyway, so yeah, this is where this kind of parse XContent pattern is fairly common. Actually, this one is a little bit different. A lot of parse XContent calls tend to be static methods. SearchSourceBuilder is a little bit different in that you're expected to create the empty SearchSourceBuilder, and then you give it the XContent parser, where again, when you see XContent parser, you can kind of think of that as already being wrapped around the JSON, YAML, CBOR, Smile that it's parsing. And yeah, this parser that's wrapped around content, it says, okay, so what it's essentially stepping through token by token. And again, this is where like, well, you could just give me the underlying JSON. Like we're kind of treating this in a fairly low level sort of way, but again, it's hiding the fact that it is the Jackson parser sitting underneath. But yeah, so we can look at the current token. The the start token should always be a start object, right? Technically it will say like, well, the current token might not be a start object, but at least the next token should be a start object. This is basically just to simplify development, I think, and simplify unit tests. Because maybe you didn't advance your parser to point to the first token. Maybe it's still pointing before the first token. So anyway, so yep, it'll expect the your search request, your search request body should always start with that open curly brace if it's JSON. And then it'll say like, okay, well, I'm just going to keep iterating through stuff until I hit an end object. This big if else, like if we kind of collapse, I want to collapse the else block. Wait, no, I can collapse the individual sub things. Anyway, this big else block is if the current token is a field name, then say, I'm going to remember this field name. And then else, it's like, oh, okay, well, yeah, it should be a value. And then, yeah, what it's going to do is say like, okay, well, now I'm going to switch on the field name, right? Whatever field name was on the left-hand side of the colon, I'm going to parse that field. And yeah. Oh, yes. Yeah. So then the is value is basically saying is a primitive value. So these are all of the primitive parameters. And then of course there are a bunch of objects, right? So like a query is an object within the source. And so yeah, if the thing on the right-hand side is an object, then these are the possible objects. Query, post filter, source, aggregations, boost, slicing. Oh, yeah. Slicing is actually an interesting one that I was looking into recently. Oh, you can have a search pipeline object. This allows you to specify search pipelines inline in your search requests. Yeah. Daniel, I believe you were asking about this last week. And so yeah, here's how that works. Yeah, you can also have things that can be array. And so, store fields, fetch fields, and index boost, sorting, rescoring, stats. Yeah, the underscore source, you can specify which field you want to get from source. And then otherwise, so if it's not, oh, yeah. So this unknown key for a token in current field name. So if this is, yeah, and else here, yeah, I forget what else. Yeah, I forget what else, what other kinds of tokens you can have on the right hand side, but start array, start object, and primitive value. I think it's relatively exhaustive, so I suspect you might actually end up in this else clause. I might be wrong. And then, yeah, and then usually after you hit that final close object, there shouldn't be any trailing tokens. And so, yeah, we can also check for that. So yeah, so that's how the actual REST parsing happens. We have this inner to XContent. So this is kind of going the other way, right? So this is, you can also take the SearchSourceBuilder and turn it back into XContent, into JSON. So this actually gets used by slow logging, if I recall correctly. So, if you enable slow logs for, for your searches, and a particular request takes longer than whatever the slow logging threshold was, then yeah, it will convert back to XContent to get written to the logs. So that's how that happens. And again, it all has to be done essentially by hand. Which in a way kind of forces us a little bit to think about the serialization versus say, since this is all built on top of Jackson, obviously you could just ask Jackson to serialize things and it'll auto detect getters and it'll implicitly try to serialize things from the getters. But by making it explicit, we end up having to kind of think about backward compatibility. So yeah, it may not, it tends to be very verbose. The fact that we have to think about how to serialize and deserialize every single field versus, relying on Jackson doing it automatically. Yeah, it's verbose, but it also forces us to think about what we're doing. So anyway, so coming back here to, we were in not search request, but in REST search action. We parsed the search request. So we parsed the various URL parameters. I've temporarily renamed this to override search source with URL params. Of course, it's really called parse search source builder, but really we did that up here in the called parse XContent. So this one down here actually is kind of an interesting one. So, oh, if I recall correctly, this one here was this one that, yeah, that OAS added recently. So this was kind of an interesting one. Well, or I don't know. I personally found it mildly interesting. Previously, with a search pipeline, you could either specify a named pipeline as a URL parameter, or specify an inline search pipeline in your request body. But someone, I think it may have been Eric Pugh, was saying, hey, what I'd really like to do is send a multi-search request where each of the underlying search requests, because a multi-search request is really just several search requests, defined in a single REST request. I'd like to be able to specify a named search pipeline in each of those, but specify a different named search pipeline for each of my underlying requests. Because yeah, I can't, my different indices have different pipelines. So what OAS did was he added the ability to pass a search pipeline as a string in the request body. And if it's just a string and not an object, we'll say like, oh, okay, I'm going to assume this is a pipeline name, not a pipeline source. So yeah, that's sort of a nice change. But then it's like, okay, well, what do you do with, when there's, something specified in the URL versus something specified in the source? And yeah, this ends up making things consistent. So it ends up mapping the thing from, if there is a pipeline specified in the source, that's used as the default, but something in the request param, something in the URL parameters will override it. So yeah, that was kind of nice. That was sort of a way of offering flexibility without breaking existing users, without being too confusing, I hope. So anyway, yeah, that again, the general rule that URL parameters take precedence over the request body. Yeah, I think that's, a nice consistent rule. So this one's actually, this one's kind of interesting. I think possibly this may be one of the things that we might want to deprecate in OpenSearch 3.0. So prior to, I think it was Lucene 8. Yeah. So prior to Lucene 8, when you'd run a search on Lucene, you could guarantee that the hit count that you got back was accurate. Well, starting with Lucene 8, that's where they added the so-called block max weekend logic. Sometimes called block max wand. So what that does is it allows Lucene, when it's collecting the top documents, to sort of look at, the top end that's collected so far, look at the bottom result, the nth result, and it sees if that nth result, if its score is such that, as you're iterating through, you can look at a block level. They added, within blocks of documents, they added some statistics that would give you an upper bound on the maximum possible score of a document. Well, yeah. So based on these statistics, you could calculate an upper bound on the maximum possible score of the document within that block. And based on that, you could skip an entire block. Of course, as soon as you skip a block, you skipped some number of documents. You don't know how many, right? Because maybe, like, it's actually theoretically possible that none of the documents in the block would have matched. Again, it's just giving you a theoretical upper bound on the maximum possible score of a document in that block. It may be that, the max score would have been 0, meaning like nothing matched. But this does mean that you don't get an accurate count of how many documents matched your query. So that's where in the response that was returned, the search hits, I'm just going to go over to search hits briefly. Yeah. So total hits, once upon a time, total hits was an integer, right? Because it was the total number of hits. So with this change in Lucene 8, which I guess would have corresponded to, the Elasticsearch 6.x series. So this was well before, OpenSearch 1.0. Total hits was changed from being an integer to this object where, not an integer, but a log, a 64-bit integer. So instead of being able to say, well, the total number of hits is this, and that's definitely true, we either say, well, yeah, it is definitely true, or we say, well, this is actually a lower bound on the number of hits because I skipped some and I don't know how many I skipped. So yeah, that's why total hits had to change to becoming an object instead of, just a 64-bit integer. Well, of course, changing the response type like that would have broken some clients, would have broken some existing applications that expected total hits to come back as an integer. So that's where, yes, there's this parameter. I believe I believe you can also pass it as a setting. Try to remember. Yeah. Okay. No, this is just enumerating the various parameters. Yeah, I believe you can set it as an index setting or as a cluster setting to say, no, no, no. I always want total hits to come back as an integer because I have really old code. That said, I kind of think it might be time for us to retire this parameter, possibly in OpenSearch 3.0. We might want to say, no, going forward, you will always get your total hits as an object. This has been the default for quite a number of years now. Yeah, and so yeah, going forward, you will get back total hits as an object. The slight downside is we actually have a lot of unit tests, I think. A lot of unit tests and integration tests that that rely on this being able to override this. Because, of course, breaking backwards compatibility breaks users, but it also breaks all of your tests. But yeah, I think this may be worth changing in the future. Yeah. So yeah, I think that pretty much covers everything I wanted to touch on in REST search action. This is how we parse the requests. So now we've got a complete search request, and yeah, we want to actually execute it. So this search request has been constructed on the so-called coordinator node, right? So you send a REST request that hits unnamed, either the node that you specified in your client to say, oh, I want to talk to this node, or maybe you have a load balancer sitting in front, and the load balancer picked which node received the REST request. So it's fairly unlikely that that node is the one that actually holds all the shards, right? Because the beauty of running OpenSearch is that you have a cluster, right? You're running several nodes, and it's quite likely that you're going to have to fan out to shards that are remote. I don't think we're going to get to that remote fan out today, but just to locate us, we are still on that initial node that received the request and actually does quite a lot more before it fans out. So what this channel consumer, the channel consumer that we return, this is a fairly common pattern in these REST actions. If you were following along on the indexing side, I believe I can actually very quickly look at that one. It's prepareRequest has something quite similar, right? So this one's like, I have a channel, and based on that, I'm going to call, well, in this case, okay, it calls directly to client.index. This one's actually a little bit sneakier. Well, actually, this one's really using more of a high level API. Huh. That's actually kind of funny because this one here calls this low level execute API. In a lot of ways, actually, we could actually do this. And yeah, so instead of calling cancel client.execute, we could actually call cancel client.search, which would be more similar to what the REST index action did, right? So you call client.index, where it passed in the index request, and it passed in a callback, this listener, where really all this is doing is saying, okay, well, yeah, I want to take whatever the status is, right, and turn it back into XContent, for the response. But yeah, this one now, functionally, if we were to do this and call cancelClient.search instead of directly calling cancelClient.execute with a search action instance, let's see what this does. It calls to execute with the search action instance. So it's exactly the same, right? Like it's just what the REST search action is doing right now is it's not doing this one extra layer of indirection. I don't know. I kind of like the idea of the extra layer of indirection. I like the idea of saying I'm going to use my node client and actually call search on it. Again, functionally, it's exactly the same thing. So when we call execute on an action, this is something that I've shown a couple of times on the indexing deep dives. A short answer is there's this thing called action registry. It yeah, somewhere in the action registry there is a map from strings to action handlers. The strings are things like yeah, by comment this again. So the strings are things like these names. So indices, data, read, search. Yeah. So within the action registry, we end up registering a bunch of these. So that action registry was in action module. So was it an action module? Yeah, action registry. Oh yes, in setup action. Yeah. So this is where all the available actions get registered. So this is a recurring within OpenSearch that you have these so-called actions, and somewhere in here, this is where a bunch of the actions get registered. Actions and their sub actions. So here's where search action gets registered, and it ends up mapping to what's called TransportSearchAction. So we looked at REST search action, which is responsible for parsing REST requests. So this is the one that's responsible for handling so-called transport requests. So transport requests deal with actual objects, actual Java objects, not JSON or YAML. And it also supposes that these Java objects can be serialized, deserialized according to what we call writable. So if we look at search request, well, it extends action request, and every action request extends transport request, which extends transport message, which implements writable. So we have converted the search request from, stuff coming in with the REST API via URL parameters and the request body. We've turned to this search request object, which is an action request, which means that it can be handled by a transport action. And one example of that is transport search action. Now, on the indexing side, we saw that, okay, so the node client gets called, it does this lookup in the action registry. The action registry map from that, the action instance to the transport action. The base transport action has this method called execute. This is what the node client ends up calling, right? If we look at invocation execute, so we saw, okay, there are a couple of extra hops, but there was that execute, which said use the search action instance. Here's a request, and here's our callback listener. So that called execute calls this do execute, which calls execute locally, which figures out which transport action it is by doing this lookup in the registry, right? So this asks the registry, hey, give me the transport action for this action, and then execute locally will call execute on that action. Well, that execute method is final in transport action, so nobody can or could or is able to override it. So every transport action, this is the entry point. And the key thing here, well, we end up delegating to this other method defined in transport action. Yeah. Okay. So we set up this request filter chain, which is defined here. This calls proceed, and here's the interesting part. So it ends up calling this do execute. So whenever you're looking at one of these transport actions and you want to see what it does, go look at its do execute method. So yeah, this is generally the as far as we're concerned, this is the entry point for any of these transport actions. So we've got our search request, it was parsed. We've then mapped it to this, from the REST action to this sort of lower level, more like, okay, now I'm actually doing stuff, transport search action. Here, because, we want search requests to be cancelable. A key thing here, if we jump back to our search action for just a sec, see, we used a cancelable node client. So I'm pretty sure that means that, these REST requests, the task that was created should be an instance of cancelable task. So we wrap the callback with this timeout cancellation listener. So, we look at a cluster setting. This is the key is search.cancel after time interval. So, and then, you can also specify the search request level, but we'll always wrap one of these things with the cluster level cancellation listener, or sorry, the cancellation listener based on the cluster setting. So it'll kill your request. It'll cancel your request by returning to the listener to say like, hey, we've been canceled. It also gets the task. So it'll actually like trigger the cancellation of the task. Okay. So then we delegate to execute request. So execute request. The search async action provider. This is where, honestly, the search code, in my opinion, gets pretty confusing. But so this execute request. Oh, hey, that's me. What did I change here? I don't know why my name appears here, but apparently I did something. So what did I do? Anyway, so this execute request. So here's where we're still not actually executing the request. Really, we do a few things like, okay, there's various timing mechanisms, right? So it's nice to be able to say, okay, well, the start of the search request, this is what we're going to use as the start of the search request. So we miss out on any time spent during the REST parsing, but that tends to be very quick. So this is the start time that we're going to use for most tracking. We've got a time provider. So for unit testing purposes, the time provider takes a relative current nanos provider, which in production, you want it to be the current system nanotime, which is the number of nanoseconds since the process started, I believe. So could only be used to measure elapsed time. Is not related to like system or wall clock time. So, but it's very handy for timing things, where you take nanotime before and after, compare them, and it'll tell you how long the thing took. But of course, for unit tests, that can be wildly unpredictable. So we like to provide our own time provider so that we can, kind of make up the flow of time, which tends to be much more reliable for testing purposes. We have this somewhat newer stuff that was added this year by David and Chen Yang. So this is adding, an open telemetry span. Actually, technically, we have OpenSearch level metrics that can take pluggable implementations. In practice, the implementation that we have is open telemetry based. But yeah, so you can wrap this whole thing in a span that, yeah, will track metrics. Chen Yang introduced this idea of a search request context. This was something where we were adding various search request operational listeners, and yeah, it was all getting piled into TransportSearchAction, and we're going to get into this class called abstract async search action. Yeah, so all of that was just getting kind of piled on. It was getting a bit messy. So yeah, Chen Yang came up with this search request context that gets passed around. And this is where you can register listeners. So yeah, what else? What else has got in here? But yeah, this do execute method has actually been quite heavily worked on in the past couple of years. Here's where we added the handling for search pipelines, right? So this is the point where if your request has a search pipeline, either referenced by name or referenced by, defined inline within the search request, this is what will transform the search request and, yeah, return, the updated pipeline request. Actually, we convert every search request into a pipeline request. In practice, if you're not using search pipeline, it's just wrapped in the no-op pipeline, which does nothing. Yeah. And then this bit here. Yeah. So I'm not super proud of this, but yeah, I think this is why my name appears in the credits at the top of this method, was because of this part. That yeah, I kind of overhauled some of this. That there was, yeah, the build rewrite listener. I think I refactored that out. It was in line here, and this was getting a bit verbose. So yeah, this is all callback based, right? And with callbacks, you kind of have to work backwards. We're kind of getting to the end of time today, so yeah, the important thing here is we end up transforming a search request by a search pipeline after we do the rewrite, if I recall correctly. But yeah, so the trick is that we take the original listener that was passed to us, we get this rewrite listener, and the result of the rewrite listener gets passed into the transform request method. So yeah, we're kind of working our way backwards. But I might be misremembering. This all gets very, very confusing. But yeah, that'll be a good starting point for next time. So next time we'll be able to get into what is query rewrite. Yeah, because that's a step that's going to execute here. And how do we transform a search request with the search pipeline? We still have a ways to go before we actually start executing the search request. We're still on the coordinator node. There's quite a lot that happens. There's the coordinator level rewrite. If we get, I might take a short detour into the terms query, which is able to do a lookup. That's actually a very interesting example of a coordinator level rewrite. Essentially, it's a broadcast join. Yeah, we'll get into that next time. Yeah, yeah, and then we'll start to touch on so-called search phases. I'm not sure if we'll have time for that after looking at rewriting and search pipelines, but yeah, let's see. So thank you all for coming, and yeah, hopefully see you next Thursday.
Thanks.